guys, we have this question 5 of 2024 GCE paper 2. Mathematics, of course. So we are asked to evaluate this, and this is calculus, of course. So there is calculus and this pseudocode and flowchart. This is the flowchart, and we're asked to write a pseudocode. Okay, so let's start with this calculus question here. So this is question 5a. We are asked to evaluate the integral of the upper limit is 2, the lower limit is negative what? Negative 1, open bracket, 6x to the power 5 minus 4x to the power 4 plus 3x to the power 2 minus 1, close bracket, dx. Then, what you do here, you add you write like this, you add the powers, it will be 6 x to the power 5 plus 1. You add 1 to the power divided by the power, which is 5 plus 1, minus, this is x, it will be x to the power 4 plus 1 over 4 plus 1. Okay, then plus 3x squared plus 1 over 2 plus 1. Then the constant number here, just add x, it will change to x. There's a reason why it's like that, because a constant number, the integral constant number is the same as this negative 2x to the power 0. Okay, and this is equals, any number raised to the power 0 is 1. And when you add 1 to this, any number raised to the power 0 is 1. And when you add 1 to this one, it will be just negative 2x. So just introduce x to this one. All right, then you have 2, negative 1. So you can solve here. It will be 6x to the power 6 over 6. When you add 5 plus 1 over 6 minus x to the power 5 over 5 plus 3x to the power 3 over 3 minus x, like this. Okay, you have 2, you have negative 1, like this. Then 6 into 6, we can reduce it here. 6 into 6 is 1, so you just remain with the x to the power 6 minus x to the power 5 over 5 plus 3 into 3, 1, so we just have x to the power 3 minus x. So when you reach this stage, guys, since these are definite integrals, we can we substitute. You find the difference in the upper limit and lower limit. How? Wherever there is x here, we're going to substitute with what? With negative 2. So showing that, I'm going to say it's going to be like this: x to the power 6 minus x to the power 5 over 5 plus x to the power 3 minus x, like this. Then in this case, we're going to substitute with 2 minus the same expression here, which is x to the power 6 minus x to the power 5 over 5 plus x to the power 3 minus x. In this case, we're going to substitute with negative 1 wherever there is x. Then let's substitute. So where there's this 6, we're going to say 2 to the power 6 minus 2 to the power 5 over 5 plus 2 to the power 3 minus 2. I've just substituted x with 2. Then here it will be negative 1 to the power 6 minus negative 1 to the power 5 over 5 plus negative 1 to the power 3 minus negative 1, like this. Okay, have you seen how I've substituted? Now we can solve. 2 to the power 6 is 64 minus 2 to the power 5 is 32. 32 over 5 here plus 2 to the power 3 is 8 minus 2, okay, like this. Then you do the same on the other side. Now, when negative 1 is raised to an even number, the answer will always be positive. Okay? So, negative 1 to the power 6 will be positive 1. But this is an odd number, so it will be negative 1. Okay? So negative 1 times this negative 1 is just the 1. Then 1 over 5 like this. Then this is also not an even number, it's an odd number, so it's going to give us minus 1. Negative times negative, they are positive 1. Okay, it's as simple as this. Alright, so you can punch these on the calculator. Alright, so you can say 64 minus 32 over 5 plus 8 minus 2. Okay, this is giving me 63.6. Just try to confirm minus, which is this one. Okay, let me double check, I don't want to make mistakes here. 64. Yeah, it's correct, I'm right, it's 63.6. Then this side, you know that this will give us 0, so let's just deal with 1 plus 1 over 5. So you can say 1 plus 1 over 5 is giving me 1.2. So when we subtract these, 63.6 minus 1.2 is giving me 62.4 units squared. Okay, this is the answer to this question here. Where is the question? This question, which is question 5a. Okay, so we can go to question 5b. So question 5b is saying the flowchart below shows the steps that are carried out in calculating and displaying the area of a sector given its radius r and angle of the sector theta. Okay, then what else? So this is the flowchart. The question is write a pseudocode corresponding to the flowchart program above. So what we're going to do here, we are going to write the pseudocode. Writing a pseudocode is not difficult. So we're going to start with the first letter, which is here. So we're going to start with the start. So this is 5b. So start, okay, like this. Start. Then we'll be indenting like this. Then at the end will come like this. That's the rule. Okay. There is a complete lesson I've done. I did on flowchart and pseudocode. Okay, so start. The next items or statements here on this parallelogram was going to be enter. So you can just enter this a little bit here. So you can just write enter r and theta like this. All right. Now, when you come to this stage, this is a decision box. Is r less than 0? They're asking. It's the question. So there are two answers, possible answers. It can either be yes or no. Okay. Now to write as a pseudocode, you write as is changes to if. So you say if r is less than 0, okay, then, okay, so there are it's a condition, the if here is a condition, so there are two possible answers. It's either yes or no, okay. If yes, so then print, if yes, print, print error, whatever is inside here, print error is not valid, okay. Error is not what? Valid. Now if yes, else it means the other way around. If not, if not, else, what do you do? Else you calculate, you proceed in calculating, okay. Else, what do we do? We come here now, we'll be moving, going this side. Else area is equals to theta over 360, okay, over 360 multiplied by pi multiplied by, you know, you're using stars, r squared, okay. R squared, this means squared. All right, then after doing this, before you print, you write and if. So you see where there is enter here, the same line, just write and if, then you write print area, which is print A, okay. Oh, sorry. Okay, and if is here, then print area. The last statement here is stop. So where you started here in the same line, you can just write stop. Okay, stop. That's all. That's all. Thank you so much for watching this video. Remember to subscribe and like the video as we go to the next question, which is question what? Question 6. Okay, question 6, which is this one.